Welcome to Introduction to Data Analysis using Stata. My name is Oscar Torres Reina. Today we're gonna learn how to import data into Stata, how to do some basic cleaning and preparation, how to merge data. This is an important step because whenever you collect your own data for your own projects and the data comes from different sources, at the end you have to put them together. So we're gonna see how we do that. We're gonna get some descriptive statistics, some data visualization, a brief on how to compare means using ANOVA and t-test, and also a brief on linear regression, and how to export selected data output. Before we get started, you need to have an idea of how the data should look like. If you are collecting the data on your own or you are creating your own data sets, how do you put them in there, in what format? For the purposes of using Stata, the data should be in rectangular form. Think about Excel. If you need to put the variable names in columns and the cases in rows. So that means that each observation, if you are collecting data on, let's say, people or doing an experiment, this experiment should have, or its result should be in a row, and then you have your variables in columns. So that will be for the what is called cross-sectional data, in which we have at least one IDs. So remember, structural, rectangular, and the variables should be in columns. If you are collecting data or you are observing data that is group, for each group you have different time periods. So that will be on the example on the lower right corner. That's considered cross-sectional time series data or panel data. In this case, each member of the group is observed, or each group is observed over time, and then you also have some variables associated with that. So this is in columns. So cross-sectional data, no time involved. Cross-sectional time series, time involved. In either case, both are rectangular, and if you are putting the data into Excel, make sure that the variables are in columns. It's strongly advisable to put the first row in the data set as variable names, and data should start at the second row. At the end of the data set, make sure that there is no footnotes or anything extra that doesn't belong to the data, or that is not part of the data. That is important because you can generate issues as we work with the data. In general, just to give you an idea what the data analysis process entails or works, you normally start with a purpose or goal, usually a feasible research question. And by feasible, I mean something that you can finish in the deadline, in the time that you have to finish the research. Once you have that research question, the next step is to start collecting data, cleaning, and preparing it. And then once you have the data ready, you're going to start trying to have some visualizations to see patterns in the data, trends, possible relationships. And that will give you a little bit more of an idea where your data is and what the next steps are. Along with data visualization, you might also include some descriptive statistics. After that, then you start with the inference. And here you can also need to make use of some visualizations. And finally, once you have your final models and then your final visuals, it comes the time to do some interpretation. In general, you should expect to spend pretty much most of the time on the first part of the anatomy of data analysis, basically the research question, or trying to figure out what research question you want, data collection, the cleaning, and the preparation, and that includes the merging of the data. So you're going to spend pretty much 80% of the time doing that. Once you have that, the rest is just the 20% extra. So roughly. Basically analyzing the data using discrete statistics, visualization, inferences, and interpretation. So in this case, based on this, basic data analysis cannot be done overnight. So you need to be conscious of this, and please start early. For the exercise that we're going to show here, we are going to get data from 3 different sources. The first one is the Humanitarian Data Exchange, which provides the COVID data. The second one is the World Development Indicators from the World Bank. And the third one is the World Value Survey from Wave 7. We're going to get data about confidence in governments. The questions that we are going to address here is based on the trends that we see in COVID data in cases and deaths. We want to see whether, rich countries did better than poor ones, and whether those countries where there is a higher level of confidence in government did better than those where the confidence in government is low. And let's get started.